Good morning to all of you. My voice is clear. Please confirm me. Very good morning to all of you. My voice is clear. Please confirm me.
Yes, sir.
Okay. Let's start new chapter, bending stresses and beam. Basically, stresses in beam is divided in two parts. First is the bending stresses in beam, and second is the shear stresses in beam. Okay, can anyone tell me which kind of condition is treated as a bending stresses in beam, and which kind of condition treated as a shear stresses in beam? Can anyone tell me? Bending stresses and shear stresses. So now, whenever, suppose I will take an example of a simply supported beam. Okay. Suppose I am considering a simply supported beam. Suppose this is a simply supported beam, and it is subjected to whatever kind of load. Okay. So now, what is the main purpose of this? Now, at the end of analysis, we all have reactions. Yes or no? Support reactions in value से आपने जोड़े. Please confirm me.
Yes, sir.
Okay. So now, suppose I am drawing it from reaction. Can I able to draw shear force diagram? Can I able to draw shear force diagram from reaction?
Yes, sir.
And its shear force diagram is randomly like this. Everybody with me? And its bending moment diagram is just like this. Yes or no? This is your shear force diagram. This is your bending moment diagram. So whenever your element or your structure is subject to under action of load, okay, so it will observe that that a section under some stresses. Suppose वहाँ बीम पर लोड अप्लाई करीश, तो बीम पर ना जो लोड है, ये लोड कौन रेजिस्ट कर से? એ લોડ કોણ રેઝિસ્ટ કરશે? એના ઇન્ટરનલ ફોર્सेस રેઝિસ્ટ કરશે એવું કહી શકાય? યસ ઓર નો?
Yes, sir.
Okay, and can I say that this shear force and bending moment is nothing but its internal resistance? એના internal resistance એવું કહી શકાય, બરાબર ને?
Yes, sir.
Okay, so whenever I am applying the load on a structure, there is some kind of the stresses developed on a structure depending on which kind of load is applied. So that stresses may be a shear stress, that stresses may be a bending stress, or that stresses may be a axial stress. Okay, so now suppose I am considering a simple supported beam. Simple supported beam, it is subjected to a various kind of loading, and if I am plotting the shear force diagram and bending moment diagram, and at a particular section, if I am cutting that section, I will get a value of shear force or bending moment. Yes or no? So can I say that from that value, can I say that whatever the load is applied on a structure, that should be resisted by this shearing force and bending moment action in terms of internal resisting force? Yes or no?
Yes, sir.
Okay, so stresses developed due to bending, that is known as a basically bending stress, and stresses developed due to shearing action, that is known as a shear stress. Is it clear? Is it clear to all of you? Please confirm me. Okay, so next definition is very important, pure bending condition. I think I have already discussed that condition. Everybody with me? Pure bending condition મેં તમને already discuss કરેલી છે. Yes or no? Definition of pure bending condition.
Yes, sir.
Can anyone tell me which kind of condition is known as a pure bending condition?
મતલબ સર એ જે બીમ નો પોર્શન છે એમાં બેન્ડિંગ સ્ટ્રેસ સિવાય કઈ નથી લાગતું.
Okay, can anyone tell me any more answer? There are 34 people in a room. Please give me answer. Okay, so what is a pure bending condition? Okay, I am telling one definition. First, before starting pure bending, I am telling some definition of bending stresses. Just listen to me. When a beam is subjected to lateral load, now lateral load, that is transverse load. Yes or no? Now, can anyone tell me which kind of load is known as a lateral load? Which kind of load is known as a lateral load? Can anyone tell me? It is very important, lateral and longitudinal. Suppose this is your beam. Okay, so can I say that this is your major axis? Yes or no? And other rest of two axes your minor axis? Please give me response.
Yes, sir.
Okay, so now suppose I am telling that your forces, suppose your forces acting along. Now listen to my word carefully, because keep in mind these words I will repeat in next semester lots many time, and amount explain nahi karu. Okay, બે word use કરું છું. One is along and second is around. Okay, first is along. Now along, that means we will consider along, that means parallel, and second is about, that means perpendicular. Everybody with me?
Yes.
Okay, along, that means parallel, about, that means perpendicular. Suppose in this beam I am considering such kind of loading. Can I say that this load is along the axis, along the major axis? Yes or no? And this is your major axis, and major axis is basically known as a longitudinal axis. Yes or no? એના સિવાયની જે બે axis છે, one is this and another is this. That is nothing but your lateral axis. Please confirm me. Okay, suppose I am applying load in this direction. So can I say that this load is about longitudinal axis? હવે જે લોડ મેં P apply કર્યો છે, that load is about longitudinal axis. Yes or no?
Yes, sir.
And whatever the load acting about longitudinal axis, that should be preferred as a lateral load or transverse load. Okay, I am repeating now. There are two major axes, two axes in your element. One is a major axis and another is a minor axis. What is a major axis? Biggest dimension is known as a basically major axis. In this case, your length is the biggest other than width and depth. Yes or no? So can I say that your length is your longitudinal direction as in term of the major axis? So if I am applying load parallel to longitudinal axis, such kind of condition is known as the longitudinal forces. But if I am applying load perpendicular or about the longitudinal axis, such kind of load is known as a lateral load or transverse load. Let's confirm it. આમાં કોઈને confusion છે? અંતિ easy language માં હું નહીં સમજાવી શકું. મેં possible એટલા example આપીને પણ તમને સમજાવ્યું. Is it clear? Please confirm me.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, now બધાએ chat box માં reply આપવાનો છે. બરાબર, જો તમે attendance માટે જ આવ્યા હો તો I am giving you Google form પહેલા ભરી લો પછી જઈ શકો છો. Clear? Please give me reply. There are 39 people in room. Okay, so now I am telling one definition. Listen carefully. When a beam is subjected to lateral load, that means transverse load, મેં અત્યારે બતાવ્યો છે, bending moment and shear force. Okay, આ produce in a beam. Suppose હું આ રીતનો lateral load apply કરીશ તો એના કારણે બીમમાં bending moment produce થશે or shear force produce થશે. Yes or no? Okay. Due to this, your beams will be tries to bend and resistance to bending moment and shear force are set up in a beam material. The process of bending will be stopped when every cross section of beam set up full resistance to bending moment and shear force. At any other point in a cross section of a beam, the stresses set up to a resistance of the bending moment, that is called bending stress or longitudinal stress. So what is a bending stress or a longitudinal stress? Bending stress is also known as a longitudinal stress. I am repeating that definition in simple word. Whenever I am applying the transverse load or a lateral load on a beam, in such a condition, or your beam tries to bend, everybody with me. Suppose I have load apply करीश, it may be possible your beam tries to bend. Please confirm me. આ રીતનું કંઈક બેન્ડિંગ થવાનો ટ્રાય કરશે.
Yes, sir.
But there is some internal resistance. There is some internal resistance in a beam. There is a internal resistance in a beam. There is some internal resistance in a beam that should be resist such kind of bending deformation in terms of bending stresses. Yes or no? ખબર પડ્યું શું કહેવા માંગુ છું? What is the exactly bending stresses in a beam?
Yes, sir.
Okay, so don't wait for other comment because મેં comment માં host only આપ્યું છે કે જેથી કરીને તમે comment કરશો તો મારા સિવાય કોઈ જોઈ નહીં શકે. ઓકે, તો બધાએ રિપ્લાય આપવાનો. એક જણ રિપ્લાય કરો પછી હું રિપ્લાય કરવાનો વેઇટ ના કરો. You can't see your team members comment. नहीं देखी सको તમે. I have now change my group rule. Okay, मैं rules change કર્યા છે. So now I think આમાં કોઈને ડાઉટ નથી. Similarly એક shear stress distribution સ્ટાર્ટ કરતા પહેલા એક સિમ્પલ એક્ઝામ્પલ લઈએ. સપોઝ બે પ્લેટ લઈ લઉં. I think તમે ડિપ્લોમા લેવલે ભણી ગયા છો. Can I join with by using nut bolt? Yes or no?
Yes, sir.
Okay, now suppose I am applying force like this. Suppose I am applying force like this. Your surface likely to fail from this point. Yes or no? તમે આવી કંઈક એક્શન પણ જોયેલી છે ક્યાંક ને ક્યાંક જોઈ હશે.
Yes, sir.
બરાબર ને? કદાચ આઈ થિંક સીએસ સ્ટ્રેસમાં અલ્પેશ સરે ભણાવી પણ લીધું હશે. આવી રીતનું કંઈક ફેલિયર હશે. I am not good in a drawing. Okay, so આવું કંઈક સિયર ફેલિયર હશે પ્લેટના જંક્શન આગળ. Yes or no?
Yes.
Okay.
Yes,
So
sir.
now at this surface some stress is also developed. Yes or no?
Yes, sir.
That stresses is nothing but shearing stress. That stresses is nothing but shearing stress. Okay, so shearing stress શું કહે છે? At any cross section of a beam, shear stress set up to raise a shear force. That is nothing but shear stress. Okay, આ જે પણ shear stress develop થાય છે, આ જે પણ shearing force setup થાય છે, એને resist કરવા માટે જે stresses develop થશે એને કહીશું આપણે shear stress. Okay, now let's move to the actual definition of pure bending in a beam. Okay, so now today's lecture is very important, so let's lost many time derivation is asked in examination. Okay, so now we will deal with the derivation. Before starting derivation, I am explaining definition of the bending stresses in beam. Okay, bending stresses in beam, that is nothing but whenever you are considering any element or any section or any beam. Okay, if there is a only bending action appear in that particular section. Okay, only bending stresses are appear in your section. Such kind of condition is known as the pure bending condition. That means no shear stress, no axial stress. Yes or no? I think I was already સમજાયેલી છે. Okay, so if we consider exact definition, when a beam section is subjected to only bending moment, that means no shear force, no axial load, no torsion. Such a bending call is known as a bending, pure bending or simple bending. Okay, so now it's simple example. Suppose I am considering the simply supported beam subjected to 2-point load. Okay, its distance from both ends is similar. This is A, B, C. I hope all of you are knowing. I hope all of you are knowing rough shear force diagram shape and bending moment diagram shape. Suppose અહીંયા તમારું રિએક્શન હશે, તમારે ઉપર જવું પડશે. બંને લોડ સરખા છે, that is a condition. બંને ડિસ્ટન્સ સરખા છે, that is a condition. સ્ટ્રેટ જવું પડશે. ડાયાગ્રામ અહીંયા તમારો બંધ થઈ જશે. અગેન આ બે પોઈન્ટ ની વચ્ચે લોડ નથી એટલે મારે અગેન સ્ટ્રેટ જવું પડશે. માઇનસ પી જેટલું ડાઉન જવું પડશે અને અહીંયાના રિએક્શન થી ડાયાગ્રામ બંધ થઈ જશે. This is your shear force diagram. But if I am plotting a bending moment diagram, your diagram is just like this, and this. Everybody with me, please confirm me. How quick diagram આવશે?
Yes, sir. Yes, sir.
Okay, so now just visualize that in this portion there is no shear force. Yes or no? But
Yes, sir.
You are visualize there is some kind of moment available here. Okay, this condition is nothing but pure bending condition. Suppose કોઈ સ્ટુડન્ટ ને વેરીફાઈ કરું છું, તો એના માટે હું એક સિમ્પલ એક્ઝામ્પલ આપું છું. તમે એનો શિયર ફોર્સ ડાયાગ્રામ અને બેન્ડિંગ મોમેન્ટ ડાયાગ્રામ ડ્રો કરજો. ઓકે, એક સિમ્પલ એક્ઝામ્પલ આપું છું, તમે નોટ ડાઉન કરવા જ કરી લો. સિમ્પલી સપોર્ટેડ બીમ કન્સિડર કરી દો. બંને એન્ડ ઉપર 10 કિલોન્યુટન નો લોડ એપ્લાય કરી દો. 2 મીટર ઇઝ અ ડિસ્ટન્સ. ઓકે, આના માટે તમે સિમ્પલ સપોર્ટ રિએક્શન કેલ્ક્યુલેટ કરીને એસએફ ડાયાગ્રામ, બીએમ ડાયાગ્રામ ડ્રો કરજો. ઓકે, સો આર યુ એબલ ટુ પ્લોટ સચ કાઇન્ડ ઓફ ડાયાગ્રામ? મેં તમે જે રેન્ડમ ડાયાગ્રામ ડ્રો કરો તમે પ્લોટ કરી શકશો. ઇઝ ઇટ ક્લિયર ટુ ઓલ ઓફ યુ? પ્લીઝ કન્ફર્મ. Is it clear? Can I remove this? Can I remove this? Please confirm me. Okay. So now next is a very important concept. Assumptions in a theory of pure bending. Assumption in a theory of pure bending. Okay, theory of pure bending na assumptions. So now let us start assumption of theory of pure bending. Okay. Can anyone tell me? I think you are already studied this topic from your diploma level. Okay, first assumption is that material of beam is perfectly homogeneous. Okay, material of beam is the homogeneous. Can anyone tell me which kind of condition is known as homogeneous? Second is the isotropic. And third is the, can anyone tell me what is the term called homogeneous and term called isotropic? Can anyone tell me? You have mic, right? You can also tell me. Can anyone tell me what is the homogeneous and isotropic? Let's tell me. Okay, homogeneous, that means material property will be the same along the length, along the cross section. Okay, that is term known as a, yes, right one. Okay, suppose this is your section, this is your beam, or this is your pipe. Okay, whenever I will cut a section, your material property is the same everywhere. Along the length, હું section cut કરીશ તો તમારી material property change ના થવી જોઈએ. Now can anyone tell me what is the term called isotropic? Isotropic કોને કહીશું? What is isotropic? The material property is same in all direction. That is the that is homogeneous. Pius, that is homogeneous. I asked about isotropic. Okay, isotropic, that means suppose you are considering a beam. Okay, while I am considering the beam, your beam having a cross section. But which value will be same? Which value will be same? Okay, so this is your beam element length, width, and depth. So whenever I am considering isotropic word, that means stress strain properties are same in all three directions. Everybody with me, please confirm me. Isotropic, that means stress strain properties are same in all three directions. Please confirm me. Keep in mind. That means elastic property will be same. What is the elastic property? What is elastic property? Stress, strain, yes or no? Modulus of elasticity. All these properties remain same. Okay, so now second assumption is that beam stress within the elastic limit. Okay, and Hooke's law is valid. So second assumption is that beam is stressed within the elastic limit. That means this theory is applicable for a Hooke's law. Beyond Hooke's law, you can't applicable this theory. So can anyone tell me which kind of structure will be applicable? કયા પ્રકારના સ્ટ્રક્ચરના થિયરી એપ્લિકેબલ થઈ શકશે? RCC or steel?
Steel.
I want more answer. Please give me reply. કયા પ્રકારના સ્ટ્રક્ચરમાં આ થિયરી એપ્લિકેબલ થઈ શકશે? Why steel? Give me reason. RCC માં તો નહીં થાય. RCC માં તમે એઝ્યુમ કરી શકશો કે તમારો બીમ આટલો બેન્ડ થશે, આટલા ફૂટ સુધી બેન્ડ થશે. Are you able to visualize that? Within elastic limit તમે લોડ આપશો, લોડ રિમૂવ કરશો, તમારી ઓરિજિનલ કન્ડિશન પાછી આવશે, એવું તમે વિઝ્યુલાઇઝ કરી શકશો? ફર્સ્ટ કન્ડિશનમાં જ ફૂલફિલ નહીં થાય. ફર્સ્ટ કન્ડિશન કઈ હતી? હોમોજીનિયસ મટીરીયલ. RCC નો બીમ છે, that is homogeneous material or a heterogeneous material? First of all, tell me. Okay, ત્યાં જે કેન્સલ થઈ ગયું. હા, yes, you can say steel, because whenever you are cutting a section of steel, you will get only one section, only one material. So that may be possible. You will apply this theory to steel structure. Okay, now third assumption is that the transverse section which were plain before bending remain plain after bending. Okay, that means, can anyone tell me the transverse section which were plain before bending and after bending? That means suppose this is your beam. Okay, this is your neutral axis. What is neutral axis? હું later on explain કરું છું. This is the before application of load. Your section will be a plane. Suppose I am applying the pure bending condition. Can anyone tell me? Suppose this is a simply supported condition. Okay, so can I say that it will be a bend like this? Just a minute, I am changing the color. This might be a bend like this. Yes or no?
Yes, sir. Yes.
But while I am removing
sir.
this, while I am removing this moment, your section must be under an actual condition. That is nothing but statement. That is nothing but statement. The transverse section will, which were plane before bending, after bending. Okay. I hope આમાં કોઈને confusion નહીં હોય. અને જો plane રહેતું હશે before and after bending, that means can I say that strain નું જે distribution હશે, strain epsilon ની વાત કરું છું, એ along the section. That must be a linear. Yes or no? Linear vary થતું હશે. That means suppose this is your neutral axis, this is your distance y. Suppose that distance is a 10 mm. Okay, center થી 10 mm લઈ રહ્યો છું તો એવું કહી શકાય. Center થી 10 mm લઈ રહ્યું top સુધી. આ total distance તમારું 10 mm છે. Suppose આને 5 પાર્ટમાં ડિવાઇડ કરું, 2 mm, 4 mm, 6 mm, 8 mm and 10 mm. So can I say that your strain distribution might be a linear evaluation? Suppose total strain distribution અહીંયા થાય છે 50 mm. Okay, તો અહીંયા તમારું 10 mm થતું હશે, અહીંયા તમારું 20 mm થતું હશે, અહીંયા તમારું 30 mm થતું હશે, અહીંયા તમારું 40 હશે, અહીંયા 50 હશે. Linearly vary થશે, એક સરખી vary થશે. Yes or no? 10 mm ના difference vary થશે. Please confirm me.
Yes, sir.
Okay, now એના પછીનો assumption જોઈએ. Each layer of beam is free to expand or contract. That means elastic body માટે applicable છે. Elastic, rigid body માટે applicable નથી. Okay. Now next, value of Young's modulus E is the same in either tension or compression. ચલો હમણાં એટલું યાદ રાખી લો, tension compression શું છે એ પછી વિચારજો. પણ can I say that elastic property, modulus of elasticity E is a property of material? Modulus of elasticity is a property of material. Yes or no?
Yes, sir.
And if you are considering homogeneous material, in that case, throughout the length, throughout the section, your material remains same. Your material remains same.
Yes.
Okay, so if your material remains same, whatever the portion, either tension or compression, what is the tension, what is the compression, હું તમને neutral axis માં સમજાવું છું. Okay, in that whatever tension or compression, your property of modulus of elasticity will remain constant because it's depend on material, not depend on tension, compression. Yes or no? In this particular case, in this particular case, if you are considering more than two material, in that case it may be possible, depend on which kind of zone you are considering. Say RCC structure છે અને simply supported beam વાત કરું. I think all of you are study design of the RCC beam. Okay, હું simply supported beam ની વાત કરું તો એની bending moment diagram આવો કંઈક આવશે. Yes or no? UDL માટે. So this is your tension phase plus diagram છે. So this is your bending distribution. Okay, I hope you are knowing the advanced concept. Okay, કોઈ હું ડિટેલમાં નહીં જઉં. હું પ્રેડિક્ટ કરી દઉં છું તમને, આ concept ખબર હશે. This is a compression, this is a tension. Now since this is a tension, that's why you will visualize steel at bottom page. Yes or no? In that case, suppose I will cut a section, you will see a section, a cross section detail of beam just like this. Bottom માં તમને steel દેખાશે. So in that case, this is your compression, this is your tension as per this diagram. Okay, so can I say that in a compression there will be some different E, in tension there will be some different E? Yes or no?
Yes.
Okay, but in elastic, in a pure bending theory, we have visualized that your material section is homogeneous. So this will be not applicable in this case. Okay, so I hope all of you are understand why E will be remains constant.
Yes.
Now, એના પછી the beam is initially straight and a cross section is uniform. Okay, ચલો cross section તો uniform હોઈ શકે. Now it is possible your beam must beam will be a straight in on side condition. Beam straight હોય એવું જરૂરી છે?
No.
Okay, So now again it is, that's why it is not applicable to RCC structure. It may be possible steel ના જે સેક્શનો છે એ ફેક્ટરીમાંથી ફેબ્રિકેટ થઈને આવવાના છે. ઓકે, ધેટ્સ વાય એની જે બી લેન્થ હશે સ્ટ્રેટ જ હશે અને એનું ઓરિએન્ટેશન જે પ્રમાણે તમે ડિસાઇડ કરો છો એ પ્રમાણે થવાનું છે. So that's why it is applicable for steel structure only. Now beam section is symmetrical about the plane of bending. Okay, and last is the radius of curvature of beam is very large as compared to cross sectional dimension. હું એને પછી ડિસ્કસ કરું. અહીંયા સુધી કોઈને ડાઉટ છે?
No, sir.
Now next is a neutral axis or neutral layer.
sir.
Okay, next is the neutral axis or neutral layer. It is very important concept. It is very important concept. Let's see very fastly. Okay. Suppose this is your simply supported beam. કહી શકાય? Yes or no?
Yes, sir.
Suppose in this particular beam, if I am applying load like this, your bending will be like this. Yes or no? Please confirm me.
Yes, sir.
Okay, now ચલો સિમ્પલી સપોર્ટ બીમ પર જતા પહેલા બધાએ થોડું વિઝ્યુઅલાઇઝ કરવાનું છે. તમારા હાથમાં સ્પંચ છે એવું વિચારો જે તમારા ઘરના સોફામાં યુઝ થાય. ઓકે, એના બે સાઈડથી વેઇટ આપી દો, કાં તો બે સાઈડ સપોર્ટ પ્રોવાઈડ કરી દો. ઓકે, અને નાઉ તમે એમાં એવું વિઝ્યુઅલાઇઝ કરો કે એમાં તમે 5-5 સેન્ટીમીટરના ડ્યુરેશન પર ગ્રીડ બનાવેલી છે. કરાવી કે આવી કંઈક એક્ટિવિટી કરી શકાય? Now apply load and same sponge. What would be your bending deformation? Just like this? Yes or no? Please confirm me.
Yes.
Okay, bending deformation થશે? Yes or no? Why no? Yagnik, why no? Please elaborate me. Why no? Yagnik, you have give a comment like no, but why?
Yes.
થશે ને? ના સાહેબ ખબર ના પડી મને કેવું સમજાવું એમ? મારે ઓકે, મને અહીંયા ડાયરેક્ટ થિયરી ડિરાઈવ કરવાનું નથી ગમતું, તમને કન્સેપ્ટ સમજાવી રહ્યો છું. ઓકે, સો નાઉ સો સિમ્પલ વિઝ્યુઅલાઇઝ કરો આવી રીતનું કંઈક બેન્ડિંગ ડિફોર્મેશન થશે. So in that case, can I say this? Just visualize that your topmost surface change in a line and your bottommost surface change in a line. There is some difference. Yes or no? Topmost surface ની length માં જે બી ચેન્જ થશે રિડક્શન જેવું કંઈક દેખાશે અને bottommost માં ઇન્ક્રીઝ જેવું કંઈક દેખાશે. થોડું વિઝ્યુઅલાઇઝ કરો. Yes or no? So can I say that in that condition your topmost surface under a compression and bottommost surface under a tension? વિઝ્યુઅલાઇઝ કરશો તમને આવું દેખાશે. ટોપમોસ્ટ સરફેસની જે લેન્થ હશે એ રિડ્યુસ થતી દેખાશે અને બોટમમોસ્ટ સરફેસની જે લેન્થ હશે ઇન્ક્રીઝ થતી દેખાશે. થોડું વિઝ્યુઅલાઇઝ કરવું પડશે. થાય છે વિઝ્યુઅલાઇઝ?
Yes, sir. Yes, sir.
તમારે જો મોટું ઇરેઝર હોય ને, મોટું ઇરેઝર, તો એના ઉપરથી એના બે સાઈડથી પકડી બેન્ડ કરશો તો તમને ખબર પડી જશે. ટોપમોસ્ટ સરફેસમાં તમને લેન્થમાં રિડક્શન દેખાશે પણ એ સેમ ઇરેઝરની બોટમ હશે ને એની લેન્થ તમને ઇન્ક્રીઝ થતી દેખાશે. That is simple example of this case. Okay. So now, if I am considering the simply supported beam, in that case, whatever kind of load is I will apply. Your topmost surface under compression and bottommost surface under tension. Yes or no? Please confirm me.
Yes.
So now, suppose આ જે પણ deformation થાય છે એનું કંઈક origin તો હશે, એવું કહી શકાય? એનું કોઈક origin હશે. Say that point is nothing but your neutral axis. Okay, that means તમે જે કમ્પ્રેશન અને ટેન્શન ઝોન ડિસાઇડ કર્યો એનું કંઈક બાયફર્કેશન તો હશે ને, કોઈ એક લોકેશન એવું હશે કે જ્યાંથી ટેન્શન અને કમ્પ્રેશન ઝોન ડિવાઈડ થતો હશે. Yes or no?
Yes, sir.
Okay, suppose that location at this line. Okay, હું before bending consider કરું છું. Okay, that is nothing but neutral axis. So neutral axis is a dead point where there is a no tension, no compression. That means no strain, no stress. कोई प्रकारનો stress પણ નહીં આવે ને કોઈ પ્રકારનો strain પણ નહીં આવે. So neutral axis or neutral layer is a dead axis or dead layer. In that particular axis or in that particular layer, no stress or no strain should be visualized. Okay, clear છે બધાને? ન્યુટ્રલ એક્સિસ કોને કહેવાય, ન્યુટ્રલ લેયર કોને કહેવાય? હું ફરીવાર એના સ્કેચમાં સમજાવું છું તમને. જસ્ટ મિનિટ. સપોઝ ધીસ ઇઝ યોર બીમ, suppose this is your beam. Whatever kind of load I will apply, say considering this is a simply supported beam, this is your bending deformation, this is your bending deformation, but suppose this is your neutral axis. Okay, now this is your simply supported beam, so your neutral axis at its center. Okay, your neutral axis at its center. પણ અલગ પ્રકારનો સેક્શન હશે તેમાં it may be possible અલગ જગ્યાએ હશે. So what exactly is a neutral axis? If you are considering strain distribution diagram or stress distribution diagram, such kind of stress distribution should be visualized. At neutral axis, no tension, no compression. That means कोई प्रकारનો force જ નહીં આવે. That means कोई प्रकारનો strain નહીં આવે. That means no stress. Strain નહીં હોય તો stress પણ નહીં હોય. Why નહીં? Because stress is proportional to strain. Yes or no? Please confirm me. कोई strain જ નહીં આવે તો કોઈ પ્રકારનો stress જ નહીં આવે. So neutral axis is that location where no stress, no strain condition. That's all. For body, એમાં કોઈ rocket science નથી. Is it clear? Please confirm me.
Yes, sir.
Okay, બુકમાં અઘરી ડેફિનેશન લખી હશે પણ મેં તમને સિમ્પલ વર્ડિંગમાં સમજાવી દીધું. Okay. So now, whenever your beam is subjected to any kind of loading, suppose ચલો હવે કેન્ટિલેવર બીમ કન્સિડર કરીએ. સેમ સ્પંજ લઈ લો, એને એક સાઈડે ફિક્સ કરી દો અને બીજી સાઈડે ફ્રી રાખો, એની પર લોડ એપ્લાય કરો. ચલો એનું બેન્ડિંગ બિહેવિયર કેવું હશે? આવું કંઈક હશે? યસ ઓર નો? Just visualize it, your topmost surface under tension and your bottommost surface under compression. Yes or no? Top under tension, bottom under compression.
Yeah.
ઊંધું થઈ ગયું છે. So now in that case, chalo again as per our concept, suppose this is your neutral axis. So during application of load, your neutral axis does not deform. Yes or no? પણ deform થશે તો પણ એમાં કોઈ પ્રકારનો stress નહીં આવે, કોઈ strain નહીં આવે. Now suppose I am plotting here strain distribution diagram or stress distribution diagram. In assumption, we are assumed that your strain distribution should be a linear. That's why I am here applying linear. So this is a strain in a tension, this is a strain in a compression. Now suppose this kind of strain should be developed, can I say that some load should be at this surface, some load should be at this surface? Yes or no?
Yes, sir.
Okay, and suppose this is some distance. So due to this equal and opposite force, some moment will be created. Yes or no? Some moment should be created.
Yes.
Okay, to resist such a moment, internal moment should be observed in term of bending stress. Okay, so I am telling you one simple definition. When a beam length is subjected to constant amount of bending moment on one side of the neutral axis, there are compression stresses, and another side there are tensile stresses. These stresses form a couple. That means suppose અહીંયા હું constant moment apply કરું છું બીમમાં, તો તમારું બેન્ડિંગ ડિફોર્મેશન આવું કંઈક થશે અને એના કારણે કંઈક તમને કમ્પ્રેશન અને ટેન્શન સાઈડ પર તમને કંઈક સ્ટ્રેસ કે સ્ટ્રેન જોવા મળશે. ક્લિયર? એવું જ કહેવા માંગે છે.
Yeah.
These stresses form a couple whose moment must be equal to external moment. That means આ જે તમે જે બી લોડ એપ્લાય કર્યો છે કાં તો જે બી મોમેન્ટ એપ્લાય કરી છે એના કારણે જે બી સ્ટ્રેસ ડિસ્ટ્રીબ્યુશન થયું, જે પણ સ્ટ્રેન ડિસ્ટ્રીબ્યુશન થયું એના કારણે એ કેમ થશે? કેમ કે એમાં કંઈક ફોર્સ આવશે, એના કારણે થશે. એમાં કંઈક ફોર્સ એપ્લાય વિઝ્યુલાઇઝ થશે, એના લીધે એમાં કંઈક શું કહેવાય મોમેન્ટ ક્રિએટ થશે. જસ્ટ લાઈક ધીસ. સપોઝ આ ટેન્શન છે તો આમ લોડ એપ્લાય કરું છું, કમ્પ્રેશન છે તો આ રીતે લોડ એપ્લાય કરું છું. તો આ બંને લોડના કારણે કંઈક મોમેન્ટ ક્રિએટ થશે. યસ ઓર નો? અને આ જે મોમેન્ટ છે એ તમારી એક્સટર્નલ મોમેન્ટ જેટલી થવી જોઈએ. ધેટ ઇઝ નથિંગ બટ મોમેન્ટ ઓફ રેઝિસ્ટન્સ. ઓકે, ચલો આમાં એટલું ડિટેલમાં જવાની જરૂર નથી. મેં તમને ઉપરથી કન્સેપ્ટ સમજાવી દીધું છે. નાઉ નેક્સ્ટ ઇઝ અ વેરી ઇમ્પોર્ટન્ટ equation of bending stresses in beam. Equation of bending stresses in beam. Now there is some derivation. Okay, અને એ ડેરિવેશન હવે 8-9 મિનિટમાં નહીં પતે. So I am ending my lecture here. But suppose કોઈ સ્ટુડન્ટનો કોઈ ડાઉટ હોય તો મને પૂછી શકે.